We can't believe everything that we see online.
That is right, Paula. Good morning.
Deepfakes. Deepfakes.
Deepfakes. Yeah. What are they?
Tech experts are sounding the alarm over developing artificial intelligence technology, which may usher in a new generation of fake news.
Well, the so-called fake news is reaching a whole new level. We are looking at a new phenomenon called deepfakes.
Deepfake technology that uses AI to create super realistic fake videos.
Deepfakes have started to appear everywhere. It uses artificial intelligence to basically swap out one person's face for another, often to make them say or do things that are completely out of character. Despite bans on major websites, they remain easy to make and find. In a world where fakes are easy to create, authenticity also becomes easier to deny. They use machine learning to fabricate events that never happen. From wild celebrities, face swaps, to impersonations of political leaders, it can be hard to spot the difference now between real and fake. Now there's a growing concern that in the wrong hands, this technology can pose a real threat to national security. It's harmful even when people know it's not real.
Moving forward, we need to be more vigilant with what we trust from the internet.
Not everyone bought it, but technology behind such frauds is rapidly improving, even as worries increase about their potential of harm. Computers see an image far more complex than the naked eye of a human being. This is how a computer sees an image. Computers see a matrix of numbers from 0 to 255. For colored images, there are 3 channels: red, green, and blue. There will be a matrix associated with each of these channels. Each element of this matrix represents the intensity and brightness of that pixel. Here is a solution we propose as a team, using OpenCV as our library in Python, which is a popularly known library for image processing, video analysis, machine learning, etc. Using face cascading and cascading classifiers, we can detect our face and our eyes by simple AI proceed predictors. Our solution is to store the matrix encoded value of our face in terms of pixel and consider it to be a class object. Simultaneously, to store the matrix encoded value of our eyes in terms of pixel into a variable. This can be achieved by passing the pixels using a Python imaging library. First, we get a handle to the image and get the pixels of the image by using a load function. Then by naming the pixels x and y of the image for each axis. Then we loop through each of the pixels by incrementing on each time the loop gets executed, by setting y back to 0 and incrementing x by 1 when the y is out of bounds. We can do this by feeding our machines with the original and deepfake images of our eyes and lips. By this, we create a training module where the machine knows what is fake and what is real. Therefore, the machine gives an outline and output that the image is fake. Similarly, a commonly known technique of deepfake detection is landmarking, where there are multiple nodes on the face ranging from 0 to 68. This technique of landmarking can help us solve the issue of lip syncing. Simultaneously, we can also feed the machine the original and deepfakes of various lip syncs. Let me remind you that our code is not a solution, but an idea of the solution to challenge deepfakes that exist on the internet. By that, I conclude our proposal on the challenge of deepfakes. Thank you. Have a nice day.